In a historic leap for computing technology, German quantum tech firm QANT has unveiled the world's first light-based computer chip to enter production. This revolutionary chip doesn't use electricity to process information, it uses light, and that changes everything. For over half a century, we've relied on silicon chips that operate using electrical signals and electrons. These chips fueled the digital revolution, guided by Moore's law, which predicted that computing power would double every couple of years. But now, that law is breaking down. We've hit the physical limits of how small and efficient silicon transistors can get. The world needs a new approach. QANT's photonic chip marks a technological breakthrough by using photons instead of electrons to process information at unprecedented speed and efficiency. Unlike electrons, photons are massless, travel at the speed of light, and don't generate heat. This allows data to move and be processed much faster and with far less energy. QANT's chip is built on thin film lithium niobate or TFLN. This material allows ultra-fast manipulation of optical signals in the gigahertz range without the need for heat modulation. That means more speed, more precision, and drastically better energy efficiency. In fact, Quant claims this chip is 50 times faster and 30 times more energy efficient than today's best silicon chips. But that's not all. While many competitors use photons only for transmitting data, such as Intel's or IBM's optical interconnects, Quant uses photons for the entire computation process. This is true photonic computing, not just a hybrid system. Even more impressively, QANT didn't build a new facility from scratch. They upcycled an existing CMOS production line at IMS CHIPS in Germany. That means lower costs, faster deployment, and a clear blueprint for transforming traditional silicon fabs into futuristic photonic factories. Their pilot line is already capable of producing 1,000 wafers per year. So how does this compare to the competition? Companies like Lightmatter and Lightelligence are also working on optical chips, but theirs are mostly hybrids. They still rely on electricity for part of the process. And while they use silicon photonics, Quant uses TFLN, a more advanced material with better thermal and modulation properties. Intel and IBM, on the other hand, are still primarily focused on electrical chips and optical transmission, not full-on photonic logic. This makes QANT the first to combine full photonic logic, cutting-edge material science, and commercial production readiness in one package. And the applications are enormous, from AI training and machine learning to high-performance computing and sustainable data centers. The benefits are clear. This chip doesn't just run faster, it runs cooler, consumes dramatically less power, and offers the kind of computational density the industry has only dreamed about. As we face increasing demands in AI, scientific modeling, quantum simulations, and real-time analytics, silicon simply can't keep up. QANT's breakthrough could mark the beginning of the post-silicon era, where photons take over and computing enters the age of light. So here's the question: are we witnessing the future of technology being born right now, or are we still clinging to the past waiting for something better? If you believe this is the next great leap, smash that like button, share this with every tech lover you know, and subscribe for more deep dives into the innovations that are rewriting our world.